Hello everybody, how's it going? Just give me a second here, guys. Get it all set up. All right, guys. Topic we're covering right now in our Math 30-1 Rational Functions unit is called Rational Equations, guys. If you're following along with the textbook, this is topic 9.3. All right, so we're gonna start off, guys. We've covered these in my videos in I think topic 9.1 earlier on, but just kind of given a graph like this, we'll practice figuring out what the equation is going to look like. Okay, so for over here, guys, if we look at this vertical asymptote, which is x equals 3, and then this horizontal asymptote is y equals 1. Well, what we know about the transformations of these type of functions is that this is our k value, and this is our h value here. Okay, so we're going to pick those ones off just by looking at the asymptotes of these functions. So we have y equals a, don't know what the a value is yet, x minus 3 plus 1. Okay, now it's going to take another point the graph passes through. I'm going to say I'll take this point over here, which is 2, 0. I'm going to plug this in for x and y. Continue this work over here. All right, and we get, sorry, I can subtract 1 from both sides as well. So I get -1 equals a over 2 minus 3 is -1. Multiply both sides by -1, and we get 1 equals a. So the equation for this guy is y equals 1 over x minus 3 plus 1. Okay. Similarly, we're going to do the exact same thing for this next example here. We're going to start with our asymptote is translated 4 to the left, so it's going to be x plus 4. Vertical asymptote or horizontal asymptote is at y equals 1, so it's going to be our k value as well. We have -5, 3 is our point graph passing through there. So we have 3 equals a, -5 plus 4 plus 1. That means 2 equals a over -1. Multiply both sides by -1. And we get -2 equals a. So our equations can be y equals -2 over x plus 4 plus 1. And this is our equation for this rational function over here. All right, guys. So we're going to do this question very similarly for this question over here. Now, what's different about these questions over here, guys, is we have these points of discontinuity here and here. Okay, so I'll show you how to deal with those guys. But to start, guys, everything's going to be exactly the same as what we were doing before. So if I look at this guy over here, this point is, I'm going to use this point. This is 6, 2. So for the moment, guys, I'm just going to forget about this one. But I'm just going to do the question exactly the same way that I did the previous question, like this, and we'll account for this guy afterwards. So we get y equals a over x minus 1 plus 3. I'm going to fire in my point 6, 2. So we get a equals -5. So it's going to be y equals -5 over x minus 1 plus 3. Okay. Now, what we know here is that this guy, we don't really know exactly what the y value is, but that's okay. But we know that the x value is -5. Okay. So since we have a point of discontinuity here, what we want to be able to do to this one is let's take those in -5 there, guys. We're going to have a factor of x plus 5 in the numerator and the denominator. So just remember from our last topic, guys, with points of discontinuity, they happen when we have a factor in the top and a factor in the bottom. So this is still a non-permissible value of x equals -5, but it ends up canceling out something over here. Okay, so if I put this x plus 5 factor in the top and the bottom, well, that's going to lead to this point of discontinuity over here. So in the form we're asking for, y equals ax plus b x squared plus cx plus d plus k. This would be like y equals negative 5x minus 25. The bottom part is x squared plus 5x minus x plus 4x minus 5, like this. And this is our, so there's our form in this guy over here. Okay. Guys, let's do the exact same thing for this question here. I'll just use this point, which is 6, 0, as a point this graph passes through. So to start, I'm just going to forget about the point of discontinuity and figure out this guy over here. So we have y equals a over x minus 4 plus 1. I'll put in my point 6, 0. And we get negative 2 equals a. So we have this guy over here. And this one is like a negative 2, some y value. We don't know what the y value is, but that's okay. So I just want to put in x plus 2 in the top and the bottom like this. Okay, so we get y equals negative 2x minus 4. Expand this out over here. X squared plus 2x minus 4x is minus 2x minus 8 plus 1. And that's the answer for this guy over here. Okay. Bit of just more review over here, guys. We're going to be able to convert the function into the form y equals a over x minus h plus k. So we're going to use our long division for this guy over here. So in other words, x plus 2 is being divided into 2x minus 5. 2x divided by x is 2. I'm going to multiply this, and we get 2x plus 4, like this. We subtract. Negative 5 minus 4 is negative 9. Okay, so our answer is going to be y equals 2 minus 9 over x plus 2. Or I'm just going to rewrite this because the form is asking it to look like this. So it would be negative 9 over x plus 2 plus 2. Okay. All right. So looking at this, we know that our horizontal asymptote is y equals 2. Our vertical asymptote is x equals negative 2. Part B says, can you determine the equation of the horizontal asymptote without converting to the form y equals a over x minus h plus k? Okay. So guys, this is going to be a slight intro to like a calculus concept we have. And the idea for, let's just talk about what's this function going to look like for a sec. We know we have a vertical asymptote here, a horizontal asymptote over here, a value of negative 9, so we need to go 1 to the right, like 9 down way over here. This graph's going to look like, graph's going to look like this, and then like this guy over here. Now, the idea is, with this vertical asymptote like this, as x keeps getting bigger and bigger and bigger, this function is going to start approaching, or these y values are going to start approaching this one over here. So what we want to be able to do is calculate the limit as x approaches infinity. So in other words, as x keeps going to infinity, what is y approaching over here? So y is 2x minus 5 over x plus 2. Okay. Now, guys, there is more algebra to this stuff over here, which we're not going to cover in this video over here. I'll show you that one next semester if you guys take calc. But if I just put in a large value of x, say like if x equals, let's say 1,000, then 2 times 1,000, 2,000 minus 5 is 1,995 over 1,002. Now, I'm going to plug this guy into my calculator. I'm going to go 1995 divided by 1,002, and I get 1.9910 ... Okay. Now, point is over here. This number over here So we're saying it over here is that as x gets huge, in other words, as x approaches infinity, our y value is approaching 2. Now, a way we can look at that is by looking at this equation over here. Since I have a 2x minus 5 in the numerator and x plus 2 in the denominator, I'm just going to look at the coefficients of my x terms. 2 over 1 is 2. Okay, that means y equals 2 is the horizontal asymptote. All right, and so that's how that works over there. All right, example 4, determine the equation of each horizontal asymptote of each rational function. So because we're going to examine the coefficients of the numerator and the denominator. So in this case, I'm looking at the 5 over 2. Okay, there we go. For this one, it's going to be 1 over 3. You're looking at this one, this 3, 1/3 is going to be the horizontal asymptote here. Now it's a little bit trickier for this guy over here because you see I have an x squared term in the bottom, but I don't have one in the top. So for this case, if I just write in a 0x squared, just so that the x squared is the same in the top and the bottom here, I get 0 over 1, and that means y equals 0. Okay. Similarly, for example, D here, I'm going to put a 0x cubed in the bottom, and there's a 1 in the top there. That means y equals 1 over 0, which is undefined. Therefore, there is no horizontal asymptote. All right, so guys, hopefully this makes sense for kind of a little shortcut we can do. Just by taking a look at the coefficients of each term, we can figure out what the horizontal asymptotes are going to be. Okay, so guys, this is a very similar type of example to what we did before, except now we're looking at rational functions that have 2 vertical asymptotes and 1 horizontal asymptote. Okay, so what we're seeing for this guy over here, first of all, guys, tricky here, just look at the scale here. Like if this is -10, that means we're going -2, -4, -6, -8, -10. So that means each tick is worth 2. 2, 4, 6, 8, 10 going this way over here. So this equation is going to start like this. Do not know the a value, but I know I have an asymptote at -2. Therefore, x plus 2 is in the bottom. X minus 4 is also in the bottom. And so if we go 2, 4, my horizontal asymptote is at y equals 5 for this guy here. Okay. Now I'm going to take in the point 1, 14 over 3. 1 plus 2 is 3. 1 minus 4 is -3 plus 5. So I'm just going to go on my calculator. 14 over 3 minus 5 is -1/3 equals a over -9. Multiply both sides times -9. That means 3 equals a. And we get this equation over here. Similarly, guys, for example 5, we have y equals a. We have an asymptote at x equals -5 and x equals 1. So we're going to x minus 1 plus 2. I put in this point, goes in for y. This guy goes in for the 2 x's here. 20 over 9 equals a. -2 plus 5 is 3. -2 minus 1 is -3. 20 over 9 minus 2 is 2 over 9. Multiply both sides by -9. That means -2 equals a. and we get this guy right here. Okay, example 6. Algebraically determine the x and y intercepts of each rational function. Okay, so for x intercepts, I'm going to make y equal to 0. Subtract 3 from both sides. I'm going to multiply both sides by x minus 4. So we get x equals 8 over 3. So 8/3 0 is the x-intercept. All right. For my y-intercept, I make x equal to 0. 0 minus 4 is negative 4. 4 divided by negative 4 is negative 1. That means I get y equals 2. That means 0, 2 is the y-intercept. Okay. Part B is the same thing here. Okay. Guys, I'm going to screw this question a long way here first. I'm going to multiply both sides by x plus 3. X plus 3 times 0 is just 0. Okay, so we get these two guys over here. So we got 3, 0 and negative 2, 0 are the x-intercepts. Now, for this type of function over here, guys, when we have like, so there's no k value over here, it's just like a fraction divided by, so it's a numerator divided by a denominator over here. A little shortcut here, and you will see rational functions in this form over here, guys. If you just pick off like what values of x makes the numerator equal to 0, it's going to be 3 and negative 2. Well, if the numerator is equal to 0, that means the whole thing is going to go to 0 as well, right? So for the x-intercepts in a function like this, guys, all we need to do is like what makes this equal to 0 here, and what makes this equal to 0 here, which is 3 and negative 2, which would be the solutions there. Last one is to make figure out our y-intercepts. Negative 3 times 2 is negative 6 over 3. Y equals negative 2. That means 0, negative 2 is the y-intercept. Okay, so that's what this one's going to be over here. Example 7. Okay, so we want to be able to determine the roots algebraically and graphically. So, guys, we did equations like this in Math 20. Okay, so if I'm doing this question over here, I would multiply both sides of the equation by x minus 6, which is the lowest common denominator. So they cancel out over here. And I'm going to expand out x squared minus 6x minus 2x plus 12 like this. Okay, so I go minus x squared minus x squared. I get 0 equals 8x plus 12. Sorry, that's negative 8x. That means 8x equals 12. Divide by 8, divide by 8. And we get x equals 3 over 2. Okay, so this is the root to this equation over here. Now, solving this one graphically, guys, here's my suggestion over here. My suggestion is to set one side equal to 0, and that means this is going to be my y1, and this is going to be my y2. Now, the reason why I like doing this, guys, is here is that it means that your solutions are going to be your x-intercepts of this function right over here. Okay, so it's where y equals 0. Okay, so it's going to be easier to see them this way over here. So I'm just going to fire this guy into the calculator, and we get so I'm seeing something like this over here. There might be something more kind of in this region in the graph over here like that, but really we don't need to, because like this intersection point here is 3/2, 0. Therefore, x equals 3/2 is the root to this equation over here. All right? So guys, example 8 it's just almost like identical to the same one, guys, over here. So I'm not going to solve this one over here, guys. I'll let you guys kind of practice this one on your own. It should be in your notes as well. But really, guys, we're just doing the exact same steps for this question here. Okay, example number 9. Write a possible rational function with a vertical asymptote, x equals 3, horizontal asymptote at x equals 1, and a y-intercept of 2. Okay, so guys, this is very similar to the first example we did, but like this is like the h value. This is going to be like the k value here, and then 0, 2 is xy, so we use that to solve for our a value. Okay, so guys, for rational functions, we're dealing with functions in this form. Okay, so I'm just going to plug in everything I know. Y equals 2. All right, so this will be our answer for this guy here. It's very similar to ones we just got. We're giving the information in words rather than actually giving you the picture of a graph over here. Okay. All right, guys, and that is it for topic 9.3. If you have any questions, please send me a message, and I'll get back to you as soon as I can.